Hello and welcome everyone to my presentation about updating the game without rebuilding it. So the first two questions are, why would I need that and how can I do it? It gets pretty obvious for larger games that they are delivering a lot of configs, external data, but it's not that obvious for smaller games. I heard a lot of people saying like, oh, I'm making just a small game. Why would I need that? Like, what's that for? It's just another complication I need to write. And I would pretty much disagree with this. And let me tell you a story why. So let's start with a story that most probably we all had. You're a solo developer, and in this universe, no one invented Pac-Man yet. You are. So most of the gameplay is complete, and you have a feeling that this will be an absolute hit. It will be a greatest game ever. But there is still one big problem: the feeling. You played the game so many times over and over and over again developing it that you tend to put it on an impossible level of difficulty. Like the game is so easy for you that you can beat it easily, but no one else can. And this may be a common situation where you may be a good developer, but you may not be a good designer or may not be a good art person. So what now? Like we've got the game almost finished. It needs some tweaking, and what now? So you need help with tweaking the game, and you know it. You are already frustrated. You spend a couple of days trying to do this, and you can't catch the right feeling. So a wild Johnny appears. Everyone should have a friend named Johnny. If you don't have one, you can like rename one of your friends. I already have one Johnny, so a Johnny appeared and he wants to offer his help. And he is very, very, very excited about helping us tweaking the game, but he has zero technical knowledge. Like he likes playing the games, but he just doesn't know how to make them. So how can he do it? It's pretty much easy. We just need to download Unity Hub, Unity Editor with proper version. Then we need to download some kind of Git client, maybe a source tree, maybe Git Kraken, maybe GitHub Desktop, whatever you prefer. Then we need to download the repository and set it up. And then we need to learn Johnny how to push. Well, sounds like pretty much a lot of work for a person who haven't seen things like this in his life. And while this might be just our friend Johnny, it might be easy with getting a learner license and things like this. If it's a corporate body Johnny, then he might need enterprise licenses, so there may come a costs. And Johnny might just simply get scared when we throw all of this software in his face. So even if Johnny will finally learn, you will either way slow down. You will end up screen sharing, setting all up, helping him out. Every time he will need to make a commit and push it, he will be terrified that he will break something. Most probably he will actually break something in the meantime. These things happen when people learn. So let's say we have overcome this. We've spent 2 days to learn Johnny everything, or maybe 1 day if he was clever. What now? Well, we can try to beautify the game. We can buy and download the Odin inspector and make our inspectors cool and beautiful. We may be clever and write our own Unity custom inspectors to make it even easier. But we are still spending time on that. Are we rapidly developing the game if we are spending yet another day or days on setting up Johnny and now making it friendly for a new user? Like, not really. And it still needs rebuilding with every single change. Like, of course, we can playtest the game in the editor. Well, that's what's cool about Unity, but there are some limitations. In the end, you will most probably need to test on a target device. Let's assume that Pac-Man you develop is a mobile game. So we have different inputs. It plays differently on mouse and keyboard, and it plays differently with touch input. And we have a different performance. Maybe you've got a cool desktop with an RTX new card, and you've got some old phone, or maybe the opposite. Maybe you have some old laptop and the newest flagship smartphone. So the performance may differ, and this may change the feeling when we have like a totally different frame rate. And we may have different target devices. So let's say this is a mobile game, and we explain to Johnny like how can you build the game. So you click build, you choose the Android, or you have it already set up. You make a build, you get the APK file, and you put it into your phone via a cable or maybe a Google Drive. And then you install it to install the unknown source applications and so on. And then he will tell you that, dude, I've got an iPhone. So this is yet another complication and yet another thing that we can get stuck on. So the coolest thing to do would be not rebuilding the game so often. So how to more or less achieve it? How can we overcome this bottleneck? Well, one of the solutions is to start with some kind of cloud, some place in the web that we can store our data. So we supply our params to a cloud, the things that we need in the game, the thing that we want to tweak. Then both the editor and the build game can access the data, download it, and use it. So then no rebuilds are required. And then we can more focus on developing, and we can deliver a build just once in a while, when we have some meaningful code changes, when we have developed a new feature, or when we have fixed some pesky bug that was lying around, and then we rebuild the thing for maybe Android, or maybe iOS, or maybe desktop application, whatever we need, and we deliver it and ship it to Johnny. So what params do we even need for such a simple game? Like, who needs things like this for a Pac-Man game? Actually, there's quite a lot of things leaked. A good start might be spreadsheets. They are not the best solution, but they are the easiest one to start with, in my opinion. And even for such a simple game, we have some params, like the timescale. We can use the Unity's timescale, or we can have some own time management system where we can just tweak how fast or how slow the game is, changing the whole pacing. Like, is this game like constantly chasing you that you need to react fast, or maybe it's a more relaxed game? We may have the player speed and the enemy speed. This may relate to the general speed of the game, but also in this example, the player speed is a bit higher than the enemy speed, so our player is able to escape the ghosts. But maybe it will be more fun the other way around, or maybe they should be equal. Beside that, we have the starting lives, we have the power-up duration, so when we pick the glowing dot and we are now in a mode where we can eat the ghosts instead of the other way around, how long does it last? And how long does that dot respawn? Also, when we eat the ghosts, they go to the middle of the screen and so on. And how long does it take for them to respawn? So I believe that having these params, not that many, for a simple game, even a Pac-Man, can really make a difference. Like, is this game cool to play, or is it like boring or impossible? So let's take a look how to actually do this. Like when to deliver, what is the crudest way to do this, and where to find more. So let us jump into the game. Here in the game, we've got a basic Unity project and some UI with all the params. So when we launch the game, we have the params field. And where are they filled from? They are filled from a Google spreadsheet, which are free, so we can experiment with them. Let's try to tweak something. Let's go with a player speed 1.2 and a time scale of, let's say, 14. It will be a very fast-paced game. Yeah, so it's 14 and 12 for player speed. This is not actually plugged in. This is just being displayed on the UI because, well, this is not really a Pacman, but we are updating it on the fly and we can check it. So what do we have here? Let's take a look at the code. We have the game data. Well, this is equivalent of the thing that we had in the Excel that we will actually have to plug in somewhere in our game systems and read this data and use them. We have the game data UI, a very simple UI thing just to display it for the purpose of this presentation. And we have the config downloader. So here is the first, maybe you don't know this, you can make start a coroutine by just changing void to IEnumerator, and it just launches as a coroutine. So it's a bit shorter. Instead of writing void start and then start coroutine, my coroutine, we can just go with IEnumerator start and it's a coroutine. So while true, we are downloading the data and then we just wait. Another cool thing is when you are in a coroutine yielding, do not call a new wait for seconds every time you wait because it drops garbage. Like you are generating garbage this way, so you can cache the wait time and just return it. If it's a fixed wait time, if you have a new wait time every time, then, well, maybe you can have a few new waits, but that's just a side thing. So in download data, we have the CRUD downloader and a data processor that are actually creating, like we download the raw data, we process the raw data, and we have the game data that we pass into the UI, and we invoke an event. So here, some other systems may update according to the data or maybe restart. And we have at the top the string to the URL we are using. So regarding the CRUD downloader, this is a very, very simple solution that is not robust, but it's simple. It was supposed to be simple. So we create a web client and we just download the string. So download the whole file with a lot of extra stuff, but this is one of the simplest start that we can do. Then we need to make some splitting of the data because we have a lot of things ahead of our data and a lot of things behind in the string. So we split the data, we split the end, we trim it with the last character. That is pretty wild, but it works, yes, and it's simple. And finally, we split it by the comma value. So that is a simple thing to start, and it's a moment in life of, I guess, every developer that once in you will reach a moment where you will be writing your own data parser, maybe for CSV, maybe for JSON, and then it will occur that it's a bit more than just splitting by comma. So in the config, there are some shenanigans like we are splitting here by a comma, so if we want more, we'll have to put the comma more, but it was supposed to be as simple as possible, and it is. So we have the data downloaded, and we have the data processor that we pass into it. We've got some sanity checks. Then we replace the dots for commas, because for floats, I couldn't use commas. I had to use dots, or it will separate them. And then we just parse it by the indexes. Like this is totally retarded, but it works. And it's a starting point. Like we can always expand it. We can always make something more with this. So that's pretty much it. That's all there is to it. Those are just two scripts with about 20 lines of code each, and we have something to start with that we can always upgrade, we can always expand this, and we can always make it like robust and a cool feature that we can reuse. So the next step you may consider are fallbacks and defaults. Some people play offline or have like a very weak web connection. Sometimes the connection fails, or the data might be broken or incomplete. We always need to be sure to have a plan for such situations. Like we cannot leave it unattended. There must be a fallback plan. One of the cool things that we can do is to supply every build with the latest config. Like when we make a build, we can just download the config right into the game and make sure that it's built in when we ship it. There are some cool things actually that I have found on the internet while searching. While searching the asset store, if we try to find something about spreadsheets, there are actually some things that might be useful. We have Google Sheets to Unity, or we have Sheets, and both of them are free. We have some Go Sheets for Unity. We have game design data, which I guess it uses spreadsheets. I have been using and playing around with this Google Sheet to JSON. It doesn't work in build because it's made as a Unity editor window and will require a bit of working around, but it's a cool place to start too. Like Asset Store is not only delivering us solutions, Asset Store is also delivering us ideas. So here we can like big kudos to the guy who created this package. It was pretty cool to have fun with. This allows us to download some data right into our game and have it as a JSON. So we can have a JSON stored as a backup plan if something goes wrong. So the outcome of this solution is that we don't need Unity, Unity Hub, Git, Git client, Git knowledge, and all the other things to tweak the game, and we don't need any licenses. We just need a Google Sheet. We can easily swap whole configs without rebuilding. Like we can have some spreadsheets prepared in advance, and we can just copy-paste them into each other and ask someone like, which version do you like more? Once set up, we can easily expand this. Even in my crudest solution I have prepared, when I would like to add a new parameter, I would have to add a new column in the spreadsheet, and I will have to update the game data with new parameter and adjust the indexes of parsing. And that would be it. It would work. Well, we can use it for other projects, and we have less builds. Having less builds is a cool thing because we are not wasting time on that. Let's say that build takes a minute, and then we need another minute or two to put it on the phone, reinstall this, and things like this. So 3 minutes top. But if we are tweaking it with every parameter change, then it gets kind of annoying because we are wasting, like, imagine doing it 10 times, and now imagine doing it 100 times. So now with this change, we may be able to more rapidly prototype things because we are focusing either on making new features or on tweaking the features we have and making the prototype feel like a real game. So I hope that you like this part. The next part is about what the other asset types, like can I do this with an audio clip, or can I upload a new texture or a new material or a new prefab or a new model? Yes, you can. Like it can be done with the addressable system. The principle is pretty much the same. We just build it differently. The Unity editor, when we download into the editor the addressables package, it can build the game. That's pretty obvious. We can build it with addressables or without. And then we addressables separately and upload them to some kind of cloud. Then the game build just downloads the addressables and uses them. Like it can be anything that we want. This may be a Christmas main menu theme where we download new sprites, where we download some audio clip with more festive music, and we can just use those. Obviously, we also need fallbacks built into the game if something goes wrong with the connection, but it can be done. And it's a bit more complicated to set up. Like it's not that easy to store your files for free somewhere and allow it to be massively downloaded. Like imagine that your game is a huge success, a lot of people play it, and a lot of people are downloading your data. So I don't think this will come with a Google Drive. It may maybe result in your Google account being suspended if you try to use Google Drive or solutions not designed for this. This might be Amazon Web Services got some things. Google got also, from I remember. There are also some other services, but usually they are paid. If you want to have some fun around, you can try maybe some free trials. There should be some laying around. But the extra benefit of addressables that I would like to show you is that we are saving a lot of memory because prefabs attached in the inspector are loaded into memory and addressables are not. Like, it was a big surprise to me when I learned it for the first time in my life that plugging the prefab into the inspector and not even using it's already loaded into memory. And do we always need it? So let's take a look at what happens. Let me change the scene to the loading addressables. We have the addressables examples, and we have, for testing purposes, we have a heavy level. This is some metro tunnel I have bought like in 2018 or 19. It's pretty obsolete right now, but it's heavy, and that's the idea. Like, every single item here on this shelf is a separate object, so it should be. Don't do this, but it's heavy, and that's the thing we want. So we have our prefab loader, which is, well, have its game object attached, and we just instantiate the prefab. That's all. So if you go to the profiler and take a look, when you have the prefab loader with no prefab, and we start the game, well, it got the wrong data from playing around. This happens. Let me resave the scene. Yeah, we've got it empty. We should be about, yeah, we are about 1.5 GB of memory usage, which is cool. And now let's try to attach from the asset a heavy level, and we attach it. And now, even if we didn't spawn it, we didn't do anything, we are already grown a lot. So if we load this prefab, we'll grow even a bit more, but it's like, maybe we don't use this prefab all the time. Maybe we don't use it in every level. So why do we need this here? So what can we do about this? Well, actually, we can go with the addressables. So here we have the prefab loader is yet empty. And if you haven't done anything with addressables, let's take a quick look. What can we do? When we have our heavy level and we have the window, package manager, addressables installed, I have them installed already, we will have an extra tick box for being an addressable. This means that this thing can be addressed by its address. Yeah, that sounded like okay. So we have a copy with a heavy level addressable. This is like in the miniature, this is this metro level. And it has been assigned as an addressable, and we can put a name here. When we don't do this, Unity is giving some retarded naming that I don't like. We can use whatever we want. And then when we go to Window, Asset Management, Addressables, Groups, we will have all the things we want, which is only one. And in the default local group, we can have more, we can have specialized groups. We have our heavy level. Okay, cool, it's in an addressable group. So how do I use it? What's the difference? So we have an addressable loader. Here, instead of game object, we use the asset reference, where we are referencing the asset that we want, and we want to load the level. We have the async operation handle that we are loading the asset async, and we subscribe to the completed. When it's completed, if it's a success, then we just instantiate the thing. There is a bit more fuss with unloading, that we need to release the asset and release the instance, but not really much different, like not really much harder code. So in the addressable loader, we have a cool pickup, a cool picker, and we can just choose none, or we can choose the heavy level here. So the cool thing we can do here is we have the addressable already attached, and let's take a look at the memory. We'll most probably need to restart. Yeah, we need to restart for some reason. It didn't like update properly. Yeah, and doesn't want to listen to me now. Come on. So we have the prefab loader empty, addressable loader with attached the addressable level, heavy level addressable. That's safe. And let's start it again. Yeah, it got like the proper memory now. Yeah, we are at about 1.5, and we have the reference still intact. So now only when we will load the addressable, we will, yes, we have increased, that's expected. We have loaded a heavy thing. We have loaded like a whole big level. This is an old asset, and when I put it in the newer Unity, the materials broke, and I didn't have time to fix them, but we have the level. So that's cool. Another thing is when we will unload this, maybe it will most probably work in a build, but it should free the memory after a while. So that's also a cool thing if we want to save some memory. So even if you don't want to bother with uploading the addressables to a cloud and download them, you don't think you're going to be this dynamic with your game, it still might be worth to go and play with addressables because you can save a lot of memory. Just there is one drawback. The assets will load a bit slower. When we have them attached as a prefabs, it's easier because we have them already loaded in memory. When it's addressable, we don't. So it would take a bit longer to load them into the game, but it depends maybe on the asset type or on the game you are doing. So that were the extra benefits of addressables. Unfortunately, I will not be able to show the whole pipeline of delivering them. If you would want to deliver them dynamically, this will require there are some addressable tweaking options from the addressable asset data that we will need to fill in. There's like a lot of settings to configure, and this will require like a separate lecture just how to set this all up. It's a cool feature that you can try out, but I really advise to take a look into this, but also to take a look at the addressables themselves. So where to now? You can play out with addressables usage, as I said, try to save some memory, and when you get comfortable with them, you can try delivering them dynamically. You can think of a robust solution for delivering configs that you can reuse. It will be a cool package to have in your own assets, your own parser, and your own downloader that you can reuse for every game, so you can easily and quickly prototype with them. We should remember about scaling. Every time we add things, we should ask ourselves like how this will scale, how much work is it to add a new parameter in there, how much work for how many people do I need to learn some new things to do this. So try to keep it simple. Also consider playing with validation, any data that we download, like the player speed. Do we want it to be negative? What will happen if it's -5? Or what happens when it's 0? Like, do we allow this? We validate it and maybe throw an error, like it shouldn't be below 0. But the possibilities are pretty much endless. So thank you for listening to my presentation. I'm hoping that this will give you some food for thought as to what can be done, where you can look for more things to prototype better games that you can then easily expand into something bigger and cool to play, and to explore the possibilities of delivering assets and configs, because they are pretty much endless and you can do whatever you want. And that is the cool thing that you should consider taking a look at. So thank you again for taking a look, and have a good day. Bye.
Hi all, my name is Lazoriv. I am gamer, lead full stack engineer with development experience more than 10 years, 8 of them in game development, and I create a lot of prototypes. And today we will speak about how to create a scalable prototype and how to create it easy. So typical prototypes problems. It's poor code quality and chaotic project hierarchy, chaotic dependency in the code where you don't know what dependency of this class or some else or different side of this model and trying to freeze everything, premature optimization, neglect of his principle, and try to create a very powerful system from the start. So we create a tower defense prototype with my teammate, and why tower defense? Because it was cool, and that's all. We just decide which one prototype we not create in the nearest time, and it's tower defense. So about our tower defense prototype, it's scalable, of course. It's easy to modify or add a new monster, tower, landscapes, levels, etc. And we add a little bit server side. It's just for example, and it's just sending for wave or monster settings like configs and that all. But it's demonstration how we can add the server side in easiest way. Okay, and our project scheme. So endpoint, it's Bootstrap, and Bootstrap initialize the system, some system sense. It's like camera, listener, audio listener, and setters, and lobby. Lobby for now is just one button, like start game, but it's endpoint to go to our game. So from lobby create two sense. It's like game core and context. Context is the holder of our settings, data, and setters, and game core it's business logic, which decide which one level you need to load, which setting you must put there, and which monster you need to spawn, what towers you can build, and setters. And game round is a game process for the user. It's just a game where the monsters come in the line, and the towers try to defend your main base. So what tools help us to create it? We like to use tools. We like to use tools because it's someone already creates them, and our work is became easiest. So third party, it's .win. I think a lot of you use .win. It's like a default twinner, I think, and Zenject. It's very popular too. It's a dependency injection tool. Behavior trees, not a lot of you use it like business logic, but we will talk about this. You will talk about this with my teammate. And Unirix, it's in this project we use it like just realization observable, but when it's we scale project and we need some reactive property and setters, we use an Unirix to help us. And additive sense is not like third party or tools. It's like a native feature of the Unity, and not a lot of people use it inside prototyping, but it's very help us to save time and create really a scalable prototype. So let's speak about Zenject. It's open source, of course. I think a lot of you use it. It's simply install and use. You can use project. You can install it by the Unity, like just one click, and use it very simple at all, and a lot of features and patterns realization inside the Zenject. Some of them we use, not all of course, but some of them we use, and some of them we talk about. Talk about Zenject context. Zenject context, it's a very powerful feature. It's like a container where all of your realization is. it's like big service locator. And inside this box, we have different types of this context. So we have project context dependencies available only dependencies available in the whole project at all. And inside project context, usually some settings of all app where you need these settings in all app. Sometimes like user information, user ID, you need user ID in each scene, in each moment, so it can be in the project context. Some web requests, some logic to some REST API. If you use this REST API you can use this web API in each place of your prototype. So project context is something like on the project level, high level, and it's easy to add all to project context and forget it, but it's not right, because we need inside project context only these dependencies that we really need inside whole project. Okay, so also we have a scene context. Scene context, it's dependencies available only in the current scene. So if you load some scene like Bootstrap, and there are some scene context, and if you bind something in this scene context, so when you go to the other scene, this all dependency will unavailable. So this scene context is work only for this scene. And game object context, it's very interesting one. It's all dependencies are available only in this game object and his child. So if you inside the scene have a scene context, you will have each game object with a component which need to inject something. Will have can get the dependency from scene context, like injection and that all. But if you use game object context, only the child and this game object inside can inject these dependencies that you bind inside the game object context. So a lot of words. Let's see how it works. Game objects context example with a little bit factory. As you see, there we have game object mobs and component the game object context and mono installer on the mob factory installer. So in this mob factory installer, we bind for this game object context mob factory, and mob and this in the injection at the down of the screen, we can see that we can inject this factory and use it factory create method. So but if we trying to inject this factory outside the game object mobs, like mobs path, tower spawn points, and other game objects, it's we will receive error, and because we don't need it, we need this factory only for this game object with a container. So hierarchy. Okay, let's go. Unity scene management. Unity scene management. It's only we have two different ways. Maybe a third one is like a combination, but it's hard. Anyway, the main one is like when you load scene mode single, and I think a lot of you, almost all of your time do this, but we have a lot scene mode additive. What is additive? It's like we not when we load single scene, we unload all other and loading only this one. When we create additive, it's like something like just add a prefab to your scene. It's like add the scene, and we can add the 10th scene, and all scans we can load async. So we use async scene loading, and we split the huge scene to smallest one, and that help us in the prototyping. Like when we create server side, we had a context scene where we have context like settings of our mobs, towers, etc. And we just and it take it this setting from the scriptable object like local, and we just create another one scene like web context, and just replace it. Not we don't replace all the game, we just change this little one, and it's adding to our prototype server side. So it's very interesting to use additive sense to split our logic to based. Okay, scene management with Zenject. And Zenject have very good ways to, couple of ways, of course, and all of them good, to send dependency from one scene to another one. You need this at all when you use additive or when you use single, but also we have a contract names. It's like when we have two scenes and one of them like parent and one child, and all dependency of parent child must be the same. So we have a contract name in the Zenject, but it can be used only when we use additive scene. So in our scheme, you can see we use, when we create game round from the game core, we use Zenject scene dependency. I will show in the code how it. And when we use our context and game core, between them we have a contract name. So it's we can imagine it like one huge scene with the same dependency, same context, scene context, but it in the real it's two different scenes. So let's see. Zenject scene loader example. It's how we use it. I understood that you don't know what is load scene async with inject and instance. So, but Vlad, my teammate, will show you how we use the nodes, how we use behavior trees. It's just what you need to know. It's loading the scene, and we have the container. It's a container of the. It's actually it's context of the scene, context of the other scene. So Zenject scene loader can give us possibility to bind something in scene context of this scene, of scene that we loading. So we have this context, and we can bind anything what we need. So we load from scene A, load scene B, and as you see, scene A have a lot of dependency inside, a lot of realization, and scene B needs only three dependency from scene A. It's observable mob wave, and stop time. That's all. So that looks like the load scene with Zenject loader. And contract name. At the left side of the screen, you see the parent, and the right is the child. It's you need the same name, of course. It's just a string, and it's put inside the scene context. So our game core and local game context is connected. Also, as web game context, connected by the contract name, but it's different scene. So it's a very simple way to connect two scenes that must have the same all of the scene dependencies of the scene context. They must these two scenes must have the same dependencies. And simple to change logic. As I already said, we have possibility to change only one of these a lot of scene. We just change one. We change the local game context to web game context. In local game context, we go to our scriptable object from our serialized field and put get the data from the scriptable objects and give this data to the game core. The game core and already decide what with this data to do. Our web game context go to our web API by the REST, and they take only this data from the server and from the web API, and at the same as the local game context, give it to game core. So it's very easy to change some of this block logic. For example, this web game context, and when I add the server side, I understand that it's like not total server side, but it's for an example. So I add this web game context, I think for 15 minutes from the zero. I create web API, just a controller with some data with JSON, put some models, and in the client I create this web game context. As you remember, game context have connection with the contract name with the game core, so it's both of them have contract name with the game core, and the same, of course, it's just parent contract name core for the local game context and for the web game context. So I create this web game context and just regular REST API request to get context from the web API, get it, and push it to the game core. That's all. I think 15 minutes for this, not more. And results. DI and scene management, it's easy to install and implement and use. DI, we need DI because a lot of skip this step and use singletons like easiest way or some custom server locator. But in the future, when you're trying to scale it, when you try and give this whole prototype to other person, it's can be trap. And scalable. Scalable is not only new features or something like update features. It's also a new developers. When you scale your team, when you try to split process inside your team, it's really easy when you use ADI and scene management with additive scene. You can create tasks for one of this scene and give it to one person. You can to other scene, you can give tasks to other person, and it's easy to not conflict, not resolve any merge issue. So I think, and it's not hard. It's DI, it's installed by one click and use it as example, and use it like just write attribute injection, just write binding and all. And almost all people who don't use Zendex, they just think the Zendex is too big and it's too hard to understand. You don't need to understand all Zendex to start use it. You need to only to start binding and injection. Start from this. After that, split context. After that, use factory, use pools. So it's very easy at all. And as a finish, I want to, in the end, I want to show you our prototype in Unity. As you see, Bootstrap, it's our entry point. And Bootstrap goes to the main menu and load direction light, audio listener, main camera. Okay. And the group of the mobs is the waves. We have a lot of we have huge wave model to increase health point, speed, how it look like. We have a possibility to change the landscape. When they died, it's turn on the rigid body, and as you see, it's very easiest, very simple prototype, but it was very fun to create it, and it's really interesting. Was a very interesting experience. So thank you for your attention. And about business logic, about the behavior trees and executors, will speak my teammate Vlad. Thank you. Bye.
Hello guys, my name is Vladyslav. I'm a software engineer at Innovecs company. And my topic for today is using behavior trees and executors in Unity engine. But before we start meeting with these trees, I propose you to tell some general information about trees and some core logic, how we use it in general. So, behavior trees is a tree of hierarchical nodes that control the flow of decision aimed to represent how something behaves. What is node? A node is instruction that implements any type of behavior. There are three types of nodes. First is action nodes, perform any kind of action. Condition nodes, check some kind of action. And composite nodes, contains more than one children node and dictate how they behavior or run and when they should stop. Some examples of it. Sequence execute every child node until some fail. Selector execute every child node until some success. And decorator execute only one child node with some behavior. And what is no less important, that every node has some status. For example, running, success, and fail. And there is some additional, like a data storage, which in common called blackboard. How decide to use our custom behavior trees with Unity? If you try to find some information about behavior trees, in common, the results will be behavior trees with using and creating some IEs or NPCs for games, but we just try to use it with our general game logic, for example, press button or so on. And we reach some success. At the start of our way, we just begin with use ready asset from asset store for Unity, which call behavior designer and behavior trees for everyone. It is very cool asset. It has a great intuitive visual editor, powerful API for some our purposes, runtime debugger, and error detection. But after some time of using it, we find that we just need more code enlargement and reusability. So we decided as a result to create our own solution. And as outcome, we create a good framework which help us create not only game prototypes, but publish ready games. So how we use our behavior trees? But before starting our behavior trees discovering, I prefer to learn some much important instrument called tree runner. We use it widely in connection with our trees because each runner has the main purpose to play our trees. For now, we use only coroutine behavior tree runner, which run our tree inside coroutine. But we can create any our custom runner we want. For example, multi-threading runner or so on. Inside our runner, we have Unity game cycles like update, fix update, and we can even use custom update with custom intervals. And of course, we can add some repeats with custom timeouts. For example, we have some tree which can play some effect, and we can send interval, for example, 5 seconds, and set restart when completed. And after it plays this effect, it's reach completed state, and after will be some waiting timeout over 10 seconds or any you want. And after we play this then tree again, and this will repeat it until we destroy it or any other behaviors. So, and already we reached our trees. How we use it? We have two types of our tree. Usual for implementing behavior without any parameters, and generic when we need to provide some input to this tree. As you can see in pictures, we have usual on the behavior tree and generic on the behavior tree with some type of data. And also we need our custom node implementation, which implement inode executable and inode interface. And in future, we can communicate with our nodes through this interface. Also, you can see example of these nodes. We have on start or end and execute with some status. This status is running, success or failed. Now I want to provide some examples from our demo project. For example, it will be our bootstrap tree. It's located on Bootstrap scene. It's like our entry point for our game. And this tree you can also see on the screenshot. It just contains some type of collection of trees. And on the execute stage, it's our root node. We just use for each and execute each node separately. And from editor, you can see that we have 4 trees for now. And from each tree names, you can know what this tree do. For example, load default sense tree. From name, you see that this tree loads some default scenes. What scenes you can see more detail on screenshot. It's main camera scene, audio listener scene, some directional light, and even system for input. Second tree is load main menu tree. From name, you know this tree just load main menu. And from code, you see that it's just load main menu and set this cell active. Wait tree, it's our tree that just wait some time. This time is configurable. And unload the game object send tree. This tree just unload our bootstrap scene that free some memory. What is now important that these logics can be implemented in any other stage of game. For example, unload game object sentry. We can use when we just need to close some pop-up. Our pop-ups are separated on the different scenes. We just can press some button and unload scene. In this situation, we use this unload game object sentry. And of course, I want to show some example with tree with some parameters. For example, from our game, we have some tower logics prefab. You can see on the picture. This prefab just have some trigger zone when enemies can trigger enter and trigger exit. So, and don't forget we have some enemy collider stage property. It's mono stage collection. It's like a blackboard, like some buffer of our triggers. Then to handle this in any situation and to give this to trees, and these trees can or give information or change it. So let's go to the example. We have some shooting tree. This shooting tree just contains this collection of colliders, some tower frequency rate to spawn bullets, and some bullet factory tree. This against tree, we just spawn some bullets. So where we initialize these parameters like tower frequency or enemy collider stage property. Enemy collider stage property we initialize on our enemy trigger enter and trigger exit tree. You can see we have on the pictures it's on enemy trigger enter tree we just add some collider to the collection, and an enemy trigger exit tree we just remove it from collection. As a result, we have some state. Also, we connected this tree to our runner, which is on fixed update timer. And tower frequency rate state we initialize on our tower initialize tree. We just executed on our initialization state of our tower. And as a result of this whole history, we just have some bullet factory, which is tree 2. Behavior of this tree looks more bigger, but not harder. We have two scenarios of bullet spawn accordingly of our tower level. We can buff this level on trees too. I show this logic some lately. So we have single bullet mode, which just shoots single target, single bullet, and we have a multi-bullet mode scenario, which we just single bullet to all targets. Yes, and you can hear this logic again on our screens. It's tower bullet factory. We just on execution node we check our level tower level from property and choose some mode single or multi, and single and multi node against implementation is here. Just some create some bullet, set a parent position, and just target. Target we set through target behavior trees. And this target behavior tree, we see its bullet, it's initialized tree. We send some model to him, like bullet model, which contains objective, it's our target collider, and some speed. Speed, it's like our some constant for demo project, so it's no important for now, but you can even take it from some config everywhere you want. After bullet initialization, it begins to move to our target or objective, as it can set, and with some speed. And if it destinates some target, it gives some damage to enemy and just destroy it after it. So here implementation on bullet moving tree, we just check if bullet is not null. In selector, so if you have here that bullet is null, this node returns to our selector success and it stopped. But in common, this returns false and selector continues to behavior tree if. Behavior tree if just check is our target is not destroyed. If this is not destroyed, it just move bullet. This move towards method. If this target destroyed, then we just destroy our bullet because it's not useful for us. And here you can see this bullet prefab and this bullet target move in inspector. This contains just to this property, target and speed, and transform to move. And of course, coroutine runner is fixed update. And restart when completed to restart win with without timeouts, just move. And now we and now I want to tell you something about our executors, which is a huge powerful instrument in our mono behavior tree flow. It's like just entry point to a runner and our tree. It just executes. It just start a runner and execute tree, and this runner plays this tree. It's like it's like type of chain. I don't know how to say it more correctly. For example, I would like to show more. I would like to show some parameters of our trees, of our behavior tree executor. It can be run automatically. It's, for example, we execute it on our start. It can be a cache disable. Cache disable means that in every execution of our executor, we create a new instance of tree and avoid some closures of it. And it can stop and repeat. It's, for example, if our tree is still running and we execute it again, it stopped previous tree and begins new. How we use tags? Which types of executors we have? We have behavior tree executor, behavior tree target executor to send some parameters, Unity event executors. For example, if we want to subscribe to button click on battle over. Observable executors when we want some observable values, for example, to react to some changes of values. Button executors against just which executes on button click. Input key code executor, it executes on our input from keyboard. On mouse down executors, which executes when we on mouse down to some collider, and many others, for example, on trigger enter executor and trigger exit executor, and many others. We can just create our custom executors for every needs we need. And the brilliance of the executors is that we write some tree once, and after just use it in different scenarios: on button click, on trigger enter exit, on mouse down or up, etc. It saves a lot of time and allows devs to create features as quickly as it can. For example, some code reusage. We have set active tree with which can just activate or deactivate some object, and we have two types of executor here: on mouse down and on mouse up. We have on mouse down executors. We have same executors which just react on mouse down, and different stage of tree which can activate and deactivate. And from this we easily realize some behavior of showing and hiding some objects. And here we can even optimize it. We can use same runner because it's impossible to click on the same button on the same time. And going back to our example with tower shooting, we use tower initialize executor for initializing some tower with properties. We use on trigger enter executor and on trigger exit executor for this on trigger exit and enter trees. And we use here on mouse down executor for our tower level up mechanics. Examples of this code you can see here. Tower initialize executor, it just contains some target of tower model and some factory for creation of these towers. And method set target, we just set our model to set our target. And we have example of trigger exit and enter executor. We just react on these Unity events and set some target to collider for future using it. In main menu, for example, we have a button executor, which just contains button, play button. We use this executor to start our game flow. So button executor we can see here. It just contains button and some description to button on click events. And after start game button tree, we just click on it, execute this tree with runner, and loading some contexts begins. We have two contexts, local game contexts and context with server, web API, to load some information from server, for example. And a summary using this flow, like our tree, behavior trees, executors, and runner, we create some demo projects with in tower defense genre, and no spend for it so much time. We spend near 1.5 work days for 2 developers, including some visual parts and level design. I don't know. So I think that this flow have chance to life, and in future maybe we will publish it to some as a store as a package. And now I want to show you some our game flow. And now I want to show you some our demo project. We have here our bootstrap scene with our bootstrap tree, which contains subtrees. And executor, we just run automatically. And when we start our play mode, this executor execute at the start, and we see that our flow works. We have this additional sense, like main camera, audio listener, directional light, event system, and our main menu is active. And here we have a button, just play button with button executor. We subscribe to play button, and when we click it, we just start our game. Here, level loaded, all works correct. Some towers are spawned, respawned. We can buff it. For example, to level 2, we can move in our camera, zoom out, zoom in, and we can spawn our towers in any placeholders with. And of course, we can buff our towers to max, for example, to search level, to show closes pop-up of level upping. And if you can see, our tower are shooting, mob are running, mobs are dying with ragdoll. We have some indicators of our mob health. If it's green, it's full HP. We have yellow, it's half HP, and if you have red, we have low HP, and next stage mob will die. So we can seize it just to show our trigger range. We have red HP and he died. So that's all our demo projects about. It's really not hard to create. We just separate our logics to different trees, reuse our executors in some of our trees, and as a result, we have some playable game, which can be reworked or upped in future. And this is cool. We not spend much time. We create a good code base, which represents to any good code styles, for example, solids. And this is cool. And I think that all devs must as less try to use it. And maybe to take to everyday instrumental flow. So thank you for bye.